One thing you might notice as you're testing the world you're building is that as you build objects, whether it's with the basic cubes and cylinders and things like that that Unity provides, or maybe you're using Pro Builder, if you walk into something like this arch, you don't walk through it. It's solid. And if you walk up the staircase, you go up the staircase. It's solid. You can't just pass through it like a ghost. But here's an asset that I downloaded from the asset store. It's a low polygon tree. And as I walk through, I actually pass right through the thing. I can stick my head inside and look through it. And if we add some kind of object to the scene, like a sphere with a rigid body that's subject to gravity, we would also see that it passes directly through our tree. So that's not what we want it to do. And the way we solve this problem in Unity is with something called a collider. So whether you have just made a brand new cube in Unity's basic editor, or you make something in Pro Builder, you'll notice that one of the components it has in the inspector is a collider of some kind. Any object that you can see in your Unity world is going to have not only a transform, but usually also some kind of mesh and mesh renderer, and that's the shape we're seeing that's being rendered in the 3D space of Unity. But if it's going to be touched at all and pass that information to Unity, you know, to say like either this is solid, you can't walk through it, or even it's not solid, but we just want to know that somebody touched it. Like let's say it's an invisible wall, and when you walk through it, a light turns on. Unity needs to know that, and the way it knows that something has been touched by something else is with a collider. So these colliders are automatically on objects that you generate from Unity, but a lot of the things you might either make yourself in a 3D modeling program or download from the asset store won't naturally have colliders on them when you drag in the prefab. So to make a long story short, the simplest way of doing it is to add a component to your object without a collider. Start typing collider, and you'll see your choices. We've got box colliders, capsule colliders, circle colliders, mesh colliders, sphere colliders, terrain colliders, wheel colliders, and that's just the 3D ones. Then if you were making a 2D game, there's all kinds of 2D ones as well. Easiest way to solve our problem would be with a mesh collider. And what a mesh collider is the exact same shape that the mesh is. That is to say, this tree shape is also the shape that the collider is. So the shape of the collider down here at the tree trunk is exactly the same as the tree, and all these tree branches and stuff are part of the collider too. You might think, well, that's what I would always want. Why would I ever want anything else? And a lot of times that is the easiest solution. And if we demo, you can see now our ball will bounce right off the tree trunk, and if we walk, we can't walk into the tree trunk either. So it solves our problem and we are all good, right? Well, yeah, except there are a couple of use cases where you wouldn't want a mesh collider. I'll give you two reasons why. One is it's less performant, which means Unity has to render the tree for us to look at it, but it also has to render the tree again for the sake of the mesh collider. And if the tree were a very complicated 3D model, now we've got two of them for every one we actually want in the world. So, you know, it's fine if you have one low polygon tree, but what if this was a whole forest of photorealistic trees? You know, maybe then having doubled all of the meshes would be an unnecessary amount of processing power for the computer you're running on. So that's one reason why we don't always use mesh colliders. The other reason is sometimes they can actually not give us the effect we want. So let me demo a situation where our colliders aren't working as intended. Here I've got another tree. It's got gravity on it because it has a rigid body, so when I start this game, it's going to fall down and hit the ground. But even though I have a mesh collider on it, the first thing that's likely to happen is that it's not actually going to hit the ground. It's going to pass right through. So the particular way I can fix that is here under Mesh Collider, we want to check this box Convex. And all of a sudden you'll notice that now we see a kind of wireframe green representation of what our collider looks like. Convex is basically trying to connect all the little vertices of a collider, of a mesh collider, together into one solid object so that there aren't any holes or tunnels or anything like that in your collider. Unity needs this for like dynamic physics processing. My understanding is that even if there's a mesh collider on something like this, if it's got holes in it and it's too complicated, it's just going to ignore the collider when it goes to pass through something like the floors collider. So in this case, we make this collider convex so that now we get the tree hitting the ground and not passing through. And that's cool as far as it goes. But when you look at this and think about, like, why is the tree being held up by the leaves? Like, if you think of it not as just like an object, you know, made of like a fake tree, but if this were to be an actual tree, you would want the leaves maybe to partially pass through the ground, I think, to look as if they got smushed a little bit, and you'd like it to actually land on its trunk and branches, right? Because those are the heavy parts. So this collider actually isn't the shape we want. We want some of this to be passed through and some of it to not be. So in this case, I wouldn't use a mesh collider. I would actually want a series, I think, of colliders. I could do it either with a box collider or a sphere collider, but I think I'm going to go box. And by default, it's going to try to put a box around the whole thing, which is okay, but not exactly the size we want. So instead, I'm going to change down here on the box collider settings, I'm going to change the size of the box collider, and then I'm going to change its center. And I'm basically trying to line this up with my tree trunk to make it the size and location of my tree trunk. And it can be a little bit of fussy work, especially if the numbers in here get small. You're gonna have to look at it from multiple angles. So now I'm shrinking my Y so that it doesn't go all the way to the top of the tree. I'm shrinking the size of my Z so that it's only the tree trunk. Then I'm going to recenter the Z so that it's only the tree trunk. Now here, we would probably get the effect that we're after already, but you might start to notice, you know, this rectangular box that we've got isn't following the tree trunk, and you might think, oh yeah, oh, okay, I'll just rotate it, right? But there's no rotation on this box collider, and if we rotate our tree, that's rotating everything, including the box collider. So the solution for that, if you want to get even more specific, is to child an object under our tree and put the collider on that. I'm going to right click on our tree object, create an empty game object underneath and call it collider. And then I'm going to hit the 3 dots on this box collider we've been building and copy this component. Then go into the collider and paste component as new. So now, back on the parent, I'm going to remove this box collider. And as we look here on the child, now we've got a box collider with the same properties, but the real trick is that now we can rotate the transform on this collider object that is a child of the tree and get it pointing the exact way we want. The other thing that's cool about this is you can have multiple collider components on a single game object. So, we could potentially add like a sphere collider here and try to change, where it lives, and that could be some of the leaves. And now if we test, this functions a little more like we would expect it to. It looks slightly closer to a realistic tree as it might land on the ground. The other thing that you might find you need to do in certain situations is you can even have multiple child objects beneath the parent object, and they could each have colliders, and all of these would still pass collider information up to the parent. So, if we needed our own collider here just to kind of model the branches, let's say they weren't functioning the way we wanted them to just from this component, and we needed like a little bit more sticking out for some reason this way, you could add a whole extra collider object here that could have its own rotations that are different than the previous one, so that it does what we need it to do.